Good morning, students. My name is Samuel Chukwu Emeka. As usual, in this video, we shall discuss your Module 3 homework, and that includes the measures of central tendency, measures of dispersion, and their applications. The measures of central tendency, you can also call it measures of center. It tends towards the center of the data. And also the measures of dispersion, you can also call it measures of variability or measures of spread. So go to any search engine, type in my name. Let's go to my website. The first link is my site. Click on my picture to enter the site. Mathematics, finite math, notes. The videos will be here. This video will be here in this playlist. Module 3 Homework Study Guide. So we shall compute the measures of center. We shall compute by formula. We shall compute the measures of dispersion by formula. We shall also compute the measures of center by technology. We shall also compute the measures of variability or measures of spread by technology. The technology we shall use is the StatCrunch. We shall explain the shape of distribution of data, solve real-world applications involving the measures of center and the measures of spread. Then we shall construct box plots. Some people call it a box-and-whisker plots. And then compute the 5-number summary of data. So these are the prerequisites, videos you need to view. And there are more prerequisites as well. So question 1, find the sample mean of the data. So sample mean, you use a lowercase n and x bar. X bar is the sample mean. X bar is sigma x divided by the sample size. Lowercase n is the sample size. When you view the prerequisites, you will understand these variables. So you can just add them. Sigma is the summation of the x values. You add them and you divide by 5. So the sample mean of this data is 13. Question 2. For a tennis tournament event, the broadcasters sold 59 ad slots for a total of $154 million. What was the mean price? Mean is also called average. What was the mean price per ad slot? Round to 1 decimal place as needed. So the mean is also sigma x over n, which is 154 million divided by 59. And you get approximately 2.6 million. Question 3. 4 cars of the same model crashed at 5 miles per hour. The cost of repair for each of the 4 crashes were $435, $423, $485, and $239. compute the mean, median, and mode cost of the repair. We say that the measures of SENA include the mean, median, mode, and mid-range. But in this question, we are asked to find the mean, median, and mode. So the best thing for us to do first is to arrange this data in descending order. You can also arrange it in ascending order. To find the median, you arrange the data in either ascending or descending order. For the mean, you go ahead and calculate it. You get a $395.50. Round to the nearest cent as needed. So this as needed means if it's not up to nearest cent, put it to nearest cent. And if the decimal places are more than nearest cent, then round to nearest cent. If the decimal places are not up to nearest cent, just add zeros to make it nearest cent. Nearest cent means to the hundredth, okay, to 2 decimal places. That is what it means. So if you arrange this data in order, you find the median. The median in this case is the average of the 2 middle values. It gives you $429. You see that these values tends towards the center of this data. Then for the mode, if we look at this data, the frequency of each of these data values is 1. There is no data value that appeared more than 1 time. So there is no mode. There is no mode for the data. Question 4. What measure of central tendency best describe the center of the distribution? If these are all histograms. If the histogram is symmetric, then the mean is the best measure of center to describe the center of the distribution. The mean is the best measure. But if the histogram is skewed, this is skewed left. The tail end of the distribution is to the left, and this is skewed right. Skewed right. The tail end of the distribution is to the right. If the histogram is skewed left or skewed right, then the median is the best measure of center to describe it. A statistic is said to be resistant. When do we say a statistic is said to be when do we say a statistic is resistant? When extreme values are the outliers. Very large or very small values relative to the data do not affect its value substantially. That is when we say that the statistic is resistant. Mean or median versus skewness. So we talked about it. We just mentioned it. We say it's symmetric if the mean is approximately equal to the median. Then we say the distribution is symmetric distribution. Just like we have it here. If the mean is approximately equal to the median, then it is symmetric. But if the mean is greater than the median, you see the tail end is to the right. The tail end is to the right. This is skewed right. And if the mean is less than the median, the tail end is to the left. It is skewed left. The table below shows the responses. The table shows the responses of a random sample of SNHU students taking Math 130 on how many hours per week they spend on their schoolwork. So some spend 29 hours per week, some spend 4 hours per week. So those who spend 4 hours per week, it is really, really small. You need to spend more hours per week. 4 hours is too small. Some folks spend up to 2 hours every day playing computer games, or watching Netflix, or watching Kardashian shows. But they don't want to spend up to 1 hour a day studying mathematics. They spend 2 hours watching basketball, but they don't want to spend 1 hour watching doing some mathematics. Folks, we need to, if we call things serious, we need to spend time on it. Don't you think so? Okay. Determine the shape of the distribution of hours by drawing a frequency histogram and computing the mean and the median. So we are going to use StatCrunch. We will do this in StatCrunch. Let's go ahead and do that. The nice thing about this is that there are several statistics software that has been made to simplify the work. So I'm going to enter this data right now. I will have my StatCrunch open already. And I can call this variable 1. The nice thing about this StatCrunch, if you have access to this, if you click on this data, it populates it. It goes ahead and populates it. So let me name my data hours schoolwork. School work hours. I'm using a camel case letters. Camel case. If you are naming your variable, no space. Don't use space. You see variable 2, variable 3. There is no space, so don't use space. You can use a camel case. So we have a 12. We have if I'm doing it by, you can put it in by column or by row. It doesn't matter. Let me just put it by a column. 12, 13, 15, 16, 20, 30, 8, 21, 22, 7, 4, 16, 16, 29, and 27. So the sample size is 15. Right here, the sample size is 15. Let's make sure that 1, 2, 3, 4, 5. 1, 2, 3. 3 times 5 is 15. Okay. So let's draw the histogram and then let's compute the mean and median. This is what we can do. We'll go to, if you want to, let's compute the mean and median first. So we go to Start, Summary Stats. We click Columns. And the variable is school work hours. You just click on it to get it right here. And we only need mean and median. Is that right? So we click mean. And we hold, it says select more than one with shift plus click or control plus click. Okay, select more than one with shift plus click or control plus click. I use my control and then I look for median and put it. And then I just hit compute. So if you do that, you see that the this is the mean and this is the median. School work hours. Okay. School work hours. Oh, I didn't name the variable here. But that is the way you do it for that. And if you want to draw the histogram, we go to graph. My bad. Graph. You select histogram. Start crunch is very good. You select the columns here, and don't worry about the bins. Don't worry about it. It will do it automatically, just like Excel. If you don't specify the bins. In this case, let's not specify the bin width. If you want the value above bar, you check this. If you want the value above the bar, you check that. Otherwise, you don't need to check it. So this is all you need to check right here, and you click compute. And this is the histogram right here. The nice thing about this histogram is you don't need to click on it. If you point your mouse at it, it tells you that 0 is included, but 5 is not included. Okay, from 0 to 5. Here 5 is included, but 10 is not included. From 5 to 10. So if you just point your mouse on it, it gives you that. That's the nice thing about it. Okay, so that's how you do it with the StatCrunch software. And this histogram is symmetric. The mean is approximately equal to the median, approximately 17 and 16. And because it's symmetric, the measure of center that best describes the hours is the mean. This one is another one. If you do that, you see that this is what is the tail end is to the right, is skewed right. So the median is the best measure of center to describe it. And you see that the median is less than the mean, skewed right. The next one, if you do this the way we just did it, this is skewed left. Okay, the median is greater than the mean, or the mean is less than the median. The median is the best measure of center to describe it. Okay, this is if you want the value, some people will ask me, okay, why did you put the value above bar? If you just want the value above bar, you do that. Histogram, school work hours. You come here, you want the value above bar, you compute. So it gives you the value above the bar if you want to do that. That's why I just put it here. Okay. This gives you the frequency. Yeah, but like I said, the nice thing about this is if you point your mouse, you don't need to click on it. If you point your mouse, you'll see the frequency right away. Okay. Question 9. For this data, for each data set, compute the mean and median. Let's do this one because it's a different kind of question. So we are gonna use let's go ahead and do this by technology. It saves time. Otherwise, we will spend a lot of hours here. So we don't need this. Let me just use variable 2, variable 3, and variable 4 in this case. Oh, I'm not gonna use this again, so I can just go ahead and name this my variable 1 as usual. So let's start with let's start with the first one of sample size 5, 107, 95, 103, 114, and 103. Okay, I can go ahead and delete these ones. And I'm going to go ahead and fill in these ones here. 107, 96, 95, 96, 103, 108, 114, 98, 103, 113, 101, 118. And this one is sample size 12, and this one will be 107, 96, 95, 100, 103, 95, 96, 115, 105, 109, 103, 108, 96, 114, 104, 114, 98, 103, 102, 115, 103, 113, 92, 118, 117, 101, 118, 98, 104, 98. Okay, when you're putting in this data, you should avoid distraction. Okay, you should avoid distraction, otherwise you can mess up. You can mess up even on one data. So if you're putting it in and your friend calls you to come and take some ice cream, you just don't answer him, because if you answer him, you might put in a data wrong. When you're doing statistics, you should be focused. All right, folks. The question says we should find a mean and median. Okay, so just the same thing. Start, summary starts, columns. Let's start with this one, variable 1. I want to select the sample size. Okay, then mean, you press your control, key, and then median. Compute. So I have this 5, 104.4, 103. Let's make sure I got it right here. Okay, 104.4, 103. So when you do that, this is what you get. There's a question here. Assuming that the data value of 107 is accidentally recorded as 170, recalculate the mean and the median. So let's look at all 107s and put 170s. We are trying to illustrate something here. So you close this. All the 107s put 170, 170, 170. So if you do that, you get, like, if we do this again, summary starts, columns, variable 1, and you recalculate this, hold your control key, mean and median, compute. So you will notice something, okay, and you can do this later on. You can do the rest later. You can do the rest later on for this variable 2 and variable 3. All you need to do is, you know how to do it, right? You go to start, summary starts, columns, click on the variable you want, If you want variable 2, you click on variable 2, select the sample size, hold your control key, select mean, and select median, compute. You see that this is for variable 2. And if you click on options, you can save, you can edit, you can download it, you can copy it. You can copy and paste this directly into Word or PowerPoint. Actually, that was what I did. I just copied and pasted it. I had to, first of all, put it in Word, crop it, resize it, and paste it in PowerPoint. So there is something I want us to look at. There's something I want to explain here. Look up. This is for 170. Okay. The other one is 107. 107. And I'm going to explain it right here. And you see what I'm talking about. You see what I'm talking about. Let me speak like American. You see what I'm talking about. What I'm talking about. You feel me, bro? You see what I'm talking about. Okay, see what I want to say here, folks. The median didn't change. This is for the first one, if it was 107. And this is the second one, if it is 170. So you change the data value. The mean changed. The median didn't change. You see that? Mean changed. Median didn't change. This is for the first one. If you want to do for the second one, this was 107. Okay. So you start, summary starts, columns, variable 2 in this case. Sample size, mean, median. You see this, and this is for, and then we change this to 170. Start, summary starts, columns, variable 2, sample size, mean, median. Okay, this is for that. You see, in this case again, the mean changed, the median didn't change. Do you see that? When you put in 107, you recorded it. You know, maybe you were thinking about how you would go to dance, or how you would you were thinking about something else. I don't want to say anything. Well, you were thinking about something else, okay? And data value that you were supposed to record as 107, you recorded it as 170. So what you see? So when you do that, you have messed up something, right? Don't you think so? Some people make this kind of mistake, and honestly, some of these mistakes are costly. So when you're recording data, you should be very focused not to mess up. So this is the third one for 107, and we change this to 170, and you see what I'm saying. Variable 3, sample size, mean, median. So you see what I'm saying? You're thinking what I'm thinking? So you see, in each case, the mean changes. The median did not change, even when you made that mistake. We say that the median is resistant. Because when you change the values, it didn't affect it substantially. But the mean is not resistant to this. Okay? That is what I wanted to show you. In each case, the mean increases for each sample size. The mean increases and the median remains mostly constant. For each sample size, for each of them, each sample size. Okay, you see from here, 104.4 to 117, it increased. The mean increased. Okay, because you changed it from 107 to 170. And here 104.33333 to 109.58333, the mean increased. Also from here 104.66667 to 106.76667, the mean increased, but the median remained constant. Okay. As the sample size increases, the impact of the misrecorded data on the mean decreases. Question 10. A nurse recorded the weights of 20 patients in a hospital. She noticed that one of the weights she recorded was not clear after the patient was gone. If the mean score of the weights was 82 and the mean of the 19 readable weights is 86, what is the value of the unreadable weight? This is one of the applications of mean. You also use this like in your if you wanna, some students come and ask me, hey, Mr. C, what will I earn? What grade am I gonna make on the final exam in order to get an A, or to get a B, or to get a C? What grade do I need to make? So this is an example of that kind of question here. Although I use weighted average, I use weighted average. Some folks just use average. I use weighted average. So which means not every assessment has equal weights. Okay, so for this question, we don't know the unreadable weight, so we assign the variable x. The mean of the 20 patients is this. This is the mean of the 20 patients. And the sigma x, remember that mean is a sigma x over n. The sample size is 20. So we don't know the mean. We know the mean of the 20 patients, which is 82. But we are using it so we can find the sigma x. Okay, and that gives us 1640. If you solve for sigma x, see 82 times 20. That's the sigma x, 1640. So the mean of the 19 patients, we also find the sigma x, which is 1634. So this 1634 plus x should give us 1640. And from there you can find the weight, the value of the unreadable weight. Does it make sense? Like this is saying that sum of the 19 patients plus that sum of plus that weight you didn't see will give you the total sum of the 20 patients. That is what I am trying to explain here. The total sum of the 19 patients plus the value of that unreadable weight will give you the total sum. The total sum is sigma. Summation is sigma, is a Greek word, sigma. Some of you are in sorority or fraternity. I ask my students, if you're in sorority or fraternity, why are you using Greek words? And they don't know. Okay, so that is how you find it, the value of the unreadable weight. Question 11. 4 cars of the same model crashed at 5 miles per hour, and these are the costs of the repair of the 4 crashes. Compute the range, range, sample variance, and sample standard deviation. So this is now the measures of dispersion, or measures of spread, or measures of variability. It does not concentrate towards the center. It spreads out. So the first one is the range. The range is the highest data value minus lowest data value. It gives you $241. All right. Some students have issues with this. finding the sample variance and sample standard deviation. We need to find the sample variance first. Okay, so you see we have to compute the mean. We have to, first of all, it is good to put this as a table. If you're computing it, it's good to put it as a table. You list the data values, you list the mean, and then you subtract first. Remember, this is the formula here. That's the formula. X minus x bar all squared. So you just have to do it step by step. You write the x first, you write the x bar, then you write x minus x bar, then you now square it. You square this. If you square it, square means 41 times 41 gives you this. This means 87 times 87 gives you this. This means 26 times 26 gives you this. Okay? You square it. And then when you finish it, you add it up. So go ahead and do it, and you'll see what I'm talking about. You will get this, okay, over n minus 1. Of course, the sample size is 4. I found sigma x in order to find the mean, because I needed the mean here. So when you do that, you get the variance as 11214. The square root of the variance gives you the standard deviation. Square root of the sample variance gives you the sample standard deviation, and the square root of this of the population variance gives you the population standard deviation. Question 12. Find the sample variance and standard deviation. So that's the same thing you do. Question 13. Find the population variance and standard deviation. Do you notice something here? When we talk of population mean, it is mu. We're not using x bar. Sample mean is x bar. Population mean is mu. Mu. This is a Greek word. Mu. M-U. Mu. Is a Greek alphabet. And you use uppercase n. When we use a sample, we use the lowercase n. Do you see that? Then another thing you should notice is for sample variance, we are using n minus 1. And we are using lowercase s squared for sample variance and lowercase s for sample standard deviation. Well, for population variance, you use sigma. This is a lowercase sigma. This is uppercase sigma. Okay. For the population variance, sigma squared, and for population standard deviation, sigma. And you don't do minus 1. You don't do big N minus 1. No. The sample, you do small n minus 1. See that? But for the variance, okay, and even for standard deviation, because standard deviation is just square root of all these. But for population variance and for population standard deviation, you use only big N. You don't do big N minus 1. So take note of these differences. Question 14. Which histogram depicts a higher standard deviation? So we say it's histogram B. Why? Because it has more dispersion. If you want to find this, you can draw a frequency table for both graphs and find the measures of dispersion, range, variance, and standard deviation. You see that histogram B has higher range, higher variance, or higher standard deviation. Either of them, has higher of them. Okay. The next question, GPA calculation. This is one of the applications of a mean. GPA calculation. Now, how many of you know how to calculate your GPA? Raise your hand. Well, if you don't know how to calculate your GPA and your CGPA, this video will help you to know that right now. At the end of her semester, second semester, okay, I should put second semester here. At the end of her second semester, Rita earned a B in her 4-hour algebra course, an A in her 3-hour biology course, a C in her 3-hour language course, and a C in her 2-hour art course. So let's say Rita took 4 courses this semester. I mean, you know, at the end of her second semester, let's say she took 4 courses. Of course, in the United States grading system, A equals 4 points, B equals 3 points, C equals 2 points, and D equals 1 point. F has no point. We don't use E in the US grading system, no E. It's different in some other countries. I know in Nigeria, it's a 5-point system. So in that case, A will be 5 points, B will be 4, C will be 3, D will be 2, E will be 1, and F will be 0. That is Nigeria. So just note it applies to your country. How many are you using, a 5-point scale or 4-point scale? It depends on the country. So this is assuming in the US 4-point scale. So you have the grades, you have the courses. I put it in a table to make it easier. You have the courses, you have the grades, you have the points here, and you have how many hours, how many credit hour. Is it a 4 credit hour, 3 credit hour? So you find the grade point. Okay, the grade point is the point times the credit hour. So she made a B in algebra, and that B is equivalent to 3 points. So, and it's a 4 credit hour course. So you do 3 times 4, it gives you 12. She made an A in biology, and biology is a 3-hour course. Meanwhile, A is equivalent to 4 points. So that gives her 12 points. Similarly, C in a language art course, that is a 3-hour credit course, give her 3 times 2, 6. And then 2 times 2 gives you 4 for the art course. So the GPA for that semester will be sigma grade point. You sum up the grade points all over the credit hours. Okay, not the points now, but the credit hours. So when you sum it up, you have 34 divided by 12. So her GPA for that second semester is 2.83. That's our GPA. So, you know, this is in the United States, it is, I mean, it's programmed. You have computer programs that, you know, and I would have loved my students to know how to write. You can easily write computer program in Visual Basic that can calculate this. But it's also good to know how to do it. I don't know countries that probably do not use computer software, but if any country does not use computerized program to calculate it, then there are possibilities for miscalculations or errors. So you need to recalculate it. I mean, it's not surprising even for countries that use computer programs to do the calculation. Computers make mistakes also, right? Everybody makes mistakes. That is why we are humans. So it is good to also cross-check to make sure you have the actual GPA. Everybody makes mistake. Even the IRS makes mistake in refunds. They make mistake also in refunds. Even though they use software. Even those filing taxes make mistake too. Even though they use software. I'm not going to call any software names so I don't get in trouble. Assuming now, question 16, you have to calculate your CGPA. CGPA is the cumulative grade point average. So, if she had assuming she had 3.58, she had this in the first semester. Let's say this is the second semester. Let's say she took 12 credit hours in the first semester, and she had this GPA. GPA, we round it to 2, to the nearest, to 2 decimal place. GPA, we round it to 2 decimal places. Excuse me. So, what would be her CGPA? Okay, at the end of second semester, what will be her CGPA? This is her GPA for second semester. But what will be her CGPA? Because you will need it to do CGPA every semester you take. So what you need to do is you multiply this by 12. You multiply this by 12 to find the sigma grade point. Okay, and then you add it to this 34, and you divide it by 12 plus 12. Is sigma grade point over sigma credit hour. Summation of the grade points divided by summation of the credit hours. Each semester, okay, you add the grade points and you divide it by the credit hours. That is what you do. So you find the sigma grade points, summation of the grade points for the first semester. That gives you 43. So you add it, 43 plus 34 is 77. And then you add the total credit hours for both semesters. It's 24. So her CGPA will be 3.21. You do not, and I repeat, some folks will come and do it 2.83 plus 3.58 and divide by 2. No, it's not going to work that way, folks. It doesn't work that way, no. You have to be, this is the, you have to add all the grade points, all of them, of the semesters, all the semesters, divided by all the hours of all the semesters. That is the way you will find the CGPA. You don't come and do a 2.83 plus 3.58 and you divide by 2. No, you don't do that. Okay, so this will be her CGPA, 3.21. Another application in this is, for some professors, their syllabus, they do weighted average. This is a weighted average. Yes, I also do weighted average as well, although I don't give points for attendance. I don't give points for attendance. But let's say that this professor has assessment like this. Attendance counts for 5% of final grade. Quizzes count for 20% of the final grade. Tests count for 60% of final grade. And the final exam counts for 15% of final grade. And this is what Joe earned in Joe has a perfect attendance. That is great. Okay. Of all the tests, he earned 93%. The average on all the quizzes, the average on all the quizzes he earned is 93%. Average on all the tests is 82%. And then he made 81% on the final exam. So this is the formula to calculate what he will get in the course, his grade for that course. Question 18. The pH of a solution measures the acidity or alkalinity of the solution. A pH less than 7 is acidic, pH greater than 7 is alkaline, and a pH of 7 is neutral. Compute the mean, median, and mode pH for each type of water. So when you know, how does this affect the mean and the median? What property of the median does this illustrate? Okay, so this is kind of equivalent, you know, similar to what we did initially. So go ahead and do that. If you do that, you take, in this case, they want you to find both the mean, median, and mode. Both the mean, median, and mode. So when you do that, you see that the first one, they want you to find mean, median, and mode. And then the second one, they want you to find the mean and the median. And then what property of the median does this illustrate? We've talked about this, that the median is resistant. Okay. If you look at the median for the tap water and the median for the bottled water, it didn't change at all. But the mean for tap water changed. See that? But the median for both the tap and bottled didn't change at all. You see that? So that's the resistance of the median. The median is resistant to outliers. It is resistant to outliers. Question 19. David owns a computer firm. His salary and the salaries of his 9 employees are given below. These are the salaries of him and his 9 employees. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 of them. Of course, what is David's salary? What do you think? And this is in thousands of dollars. David's salary is $75,000, of course. Determine the mean, median, and mode. You do it. Okay, you can do it by hand because the sample size is small. You can also do it by technology. So the mean salary is $50,000, median is $50,000, and the mode is $50,000. B, business has been good. As a result, David has a total of $25,000 in bonus pay to distribute to his employees. One option for distributing bonuses is to give each employee, including himself, $2,500. So that's an option, you know. If, let's say, he had a Christmas, you know, Christmas, you know, he was, I mean, very lucky. He made $25,000, you know, and he said, "Oh, wow, we have this money. We have this excess." So one option would be, okay, let me give everybody, you know, 25,000 divided by 10 is 2,500. Let me give everybody 2,500. So add the bonuses under this plan. Recalculate the mean, median, and mode. So we add 25,000 plus 2,500. Okay, 35,000 plus 2,500. Remember that these are in thousands of dollars. So when you do that, you have this $27.5 thousand, $37.5 thousand, of course, which means 37,500. So that is what it means. Then you recalculate the mean, median, and mode. Gives you this. What do you notice? All three measures increased by 2,500. Of course, because that was one option that, you know, he decided to give everybody, including himself, $2,500. As a second option, he decided to give each employee a bonus of 5% of his or her original salary. So original salary is this. These are the original salaries. So he can give a 5% bonus. That's another thing. That is another option he can choose to do. If he does it, I put it in a table. It is better to say it as a table. Original salary is $25,000, 5% of it, okay, will be 1.25. Let me show you something here. So you can see it. Calculator. Okay. So 5% is 0.05. Okay, 0.05 times 25. That gives you 1.25. So this will be $26,250. Okay, and that's the way you calculate this. Do you understand what I'm saying? That's the way you calculate it. You have a new data set. If it decides to give everybody 5%, okay, because this will be 1250. So 25,000 plus 1250. 25,000 plus 1250 will give you 26,250. So that's if you divide it, you have 26.25. Okay, you divide it by 1,000, you get 26.25, which means 26,250. Okay, yeah, but they want us not to write 1,000, so they want the 1,000 to be in words, so that's why we just wrote 26.25. We do that for all of them, and you get this, and you recalculate that. You see that all measures increase by 5%, of course. The third option, as a third option, he decides not to give his employees a bonus at all. He keeps the 25,000 for himself. So that means he had his original salary was $75,000. If he keeps the 25,000 for himself, it becomes $100. So if you recalculate the mean, median, and mode, it gives you this. So you will notice that the mean increased by 52. The mean is 52.5. Median and mode didn't change. If you look at this here, in the original data set, the mean is 50. 50, 50, 50. But in the third one, when you have 52.5, 50, 50. So how much did this increase by? From 50 to 52.5. Okay. It increased by 2.5, and that 2.5 is 2,500 if you multiply by 1,000. Okay, that 2.5 is 2,500 if you multiply by 1,000. So the mean increased by 2,500, but median and mode did not change. You compare it with the original data. For each option you do, you compare it with the original data of 50 mean, 50 median, 50 mode. Okay. The data below represents the inches of rainfall in April for the city of Y, Arizona. There's a city called Y, Arizona. Over the course of 20 years, determine the quartiles, compute the interquartile range, IQR. Then determine the lower and upper fences. Are there any outliers? So outliers are extreme observations, and lower fence and upper fence helps us to determine if there are outliers. These are the inches of rainfall. We are going to solve this by hand and also by technology. So let's solve it by hand. First of all, quartiles. When we talk of quartiles, quad. What is quad? 4. Quadrangle. Quadrilateral. For quadrilateral, any four-sided shape. Quadrant. First quadrant, second quadrant, third quadrant, fourth quadrant, quad. So when you talk of quartiles, it means you're dividing the data set into 4 parts, into 4 equal parts. Okay, and if you divide by 4, it's 100 by 4, it gives you 25. So if you look at the lower quartile, is it means like the 25th percentile. 25th percentile is the lower quartile. The middle quartile, or the median. The median is the middle quartile. That's the 50th percentile of the data. The upper quartile is the Q3. Q3, that is the 75th percentile of the data. Okay, so that is what quartiles mean. It divides the data set into 4. Lower quartile, middle quartile, and upper quartile. Of course, the last one is now the 100th percentile. So we want to find the lower quartile, the median or the middle quartile, and the upper quartile. That is what we want to find here. And then we find the interquartile range, which is the upper quartile minus lower quartile. And then we find the lower fence and upper fence to see whether we have any outliers. So let's first of all do it by hand. The first thing you do is you arrange the data in ascending order or descending order. But I would just suggest you do it in ascending order. Okay, you start from kindergarten. Okay, then you go to first grade, second grade, third grade, fourth grade, fifth grade. Ascending, it ascends. You ascend. So you ascend. Ascending order. We arrange it first. Then it will be easier for us to find the median next. And this is the formula for median. Okay, let me say this, and I explained this in the prerequisite videos. If you have like sample size of 3, of course, the median is the middle data value. So you only have one data value. Okay, when you have a sample size of 5, the median will be the third data value. If you have a sample size of 3, the median will be the second, the guy in the middle, right? If you have 5, the median will be the third guy, right? You remove the lower 2 and the upper 2, and you have the third guy. So when you but what if you have 4? What if you have a sample size of 4? So you have 2 guys in the middle. Okay, you have 2 guys in the middle. So the median will be the average of that 2 guys in the middle. That is the way we compute median. So if you have an odd sample size, like sample size that is odd, 3, 5, 7, 9, 11, you have just one guy in the middle, and that's the median. But if you have a sample size that is even, an even sample size, then 2 guys will be in the middle. 4, 6, 8, 10, 12. 2 guys will be in the middle. So the median will be the average of those 2 guys in the middle. So here we have how many? The sample size 1, 2, 3, 4, 5. 1, 2, 3, 4. 5 times 4 is 20. So we have an even sample size. So you arrange this. If you arrange this in order, you see the 2 guys in the middle. Take the mean of these 2 guys, and that will give you the median. So, and that's the 10th and 11th data values. Okay, so that is what this formula is all about. Sigma F is the N, is the sample size. Okay, take the if it's odd sample size, you only have one person in the middle. Okay, but if it's even sample size, you have two people in the middle. In this case, you have the 10th and 11th data values. 10th and 11th. That's what this th means. 10th, 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 and 11th. You know, when you pronounce th, you put your tongue, you stick out your tongue outside your teeth. Your teeth. Okay, that was when we were doing oral English in Nigeria, doing oral English, how to pronounce English words. Okay, so the median will be the mean of the 10th and 11th data values. So you have this as the median. To find the lower quartile, we want to use the lower half of the data values that are less than the median. So if you look at this, you use this for the median, the 10th and 11th values, and you got the median as 3.43. Okay, folks, see what you now do. All the data values lower than 3.43, find the median of it again. You understand what I'm saying? The median of the lower half of the data values less than this median. So all the data values less than this median, find the median again. So when you do that, what do you have when you do that? You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it will be the 10. You have 10 divided by 2 is 5. So do 4 out. 1, 2, 3, 4 out here. 1, 2, 3, 4 out here. So it will be the 5th and 6th values. 5th and 6th values. Okay. That's the way you find it. Because in this median, you have 20. So 20 divided by 2 is 10. So take out 9 out from the front. Take 9 out from the back. Take 9 out, and you're left with 10 and 11 values, because these are even sample sizes. Now, for odd sample size is much straightforward. Okay. So if you take the median of this lower half, it is known as the lower quartile, Q1, and that gives you 2.115. To find the upper quartile, use the upper half of the data values greater than the median. So which ones are greater than the median? You cancel this, and you use 3.63, 3.99 from there. Okay, you use only this. And of course, the same thing here. Take out 4 here, take out 4 here. So you have these values, 5th and 6th values. Okay, when you do that, find the median of this upper half, and that gives you the upper quartile. Then the interquartile range is Q3 minus Q1. This is the interquartile range. The fences are the cutoffs for determining outliers. The lower fence is Q1 minus 1.5 times the interquartile range. If you do that to 3 decimal places, you have this. And the upper fence is the upper quartile plus 1.5 times the interquartile range. Of course, you do PEMDAS. PEMDAS, please excuse my dear Aunt Sally. You do the parenthesis multiplication. This means multiplication. You do the multiplication first before you subtract, or before you add. You do the multiplication first. So if you look at this now, negative 2.288 and then 9.453. You come to this data and see whether you have, you don't have any negative 2.288, any values like that, and you don't have any values like 9 point something. Okay, so if you use this method, you see that it is less than the lower fence or it is greater than the upper fence. An outlier is if it's lower than the lower fence, if it's lower or less than the lower fence, which is negative 2.288, or if it is greater than the upper fence. We don't have values that are lower than that. We don't even have negatives in the data value, and we don't have up to 9 point something, okay, greater than the upper fence. So because we don't have values between that are lower than the lower fence or greater than the upper fence, there are no outliers. We're done. All the values we have are between the lower fence and the upper fence. Okay, let us use technology for this. So let me show you how to do it with technology. Okay, I'm gonna go to my StatCrunch, and let me just delete these values here. Let me use inches of rainfall. Inches of rainfall here as my variable. So 0.71, I'm entering the data now. 0.71, 0.91, 1.21, 1.4, 1.49, 1.98, 2.25, 2.49, 2.81, 2.92, 3.23, 3.63, 3.99, 4.34, 4.53, 4.93, 5.17, 5.46, 5.93, 6.33, 6.69. All right. So I come here, I go to stats, I go to summary stats, I go to columns, I select only inches of rainfall. And what do I need here? I need a, if you want, you can put the sample size. It doesn't matter. Sample size is 20 anyway. And then I press the control key. I need lower quartile, upper quartile, median. Okay. So I have I'm looking for Q1, lower quartile, then I need median, then I need upper quartile. Okay, that is what I need here. And then I say compute. So this is what it gives me here: Q1, median, Q3. Okay. And then interquartile range. I didn't put interquartile range here. You can select interquartile range. Start, summary stats, columns, inches of rainfall, sample size. I want Q1. I want median. I want Q3. And I want the interquartile range. Compute. You see that? So that's it. Box plots or box and whisker plots. Okay. This we have like what we call 5-number summary of data, and we use it, and also the fences, the lower fence and upper fence, to draw box plots. Some textbooks will say it as a box and whisker plots. This is the box here. This is the box, and these are the whiskers. That's the whiskers. All right. These are two data variables. Okay. These are two data sets. Two data sets. Data set X and data set Y. The median of variable X to the nearest integer. So this is X here. Is about 50. See that? 30, 40, 50. Like this scale is in 10 units. 10, 20, 30, 40, 50, 60, 70, 80, 90. So the median is like 50. Third quartile of the variable y. Okay, so folks, look at the thing now. In the box, okay, the first one is the lower quartile. The middle one is the median or middle quartile. And the third one is the upper quartile. Then this is the minimum and this is the maximum. If we have any outliers, we use asterisks to mark the outliers. But here in this data set, we don't have outliers. So this is the minimum right here, the whiskers. The minimum, the maximum, minimum, lower quartile, median, upper quartile, maximum. Minimum, lower quartile, median, upper quartile, maximum. We don't have outliers here. If we had outliers, we'll use asterisks to mark them. So the median is 50. The third quartile of Y is like 48. You see that? This is the third quartile, upper quartile, or the third quartile. Median, you can also call it second quartile. Lower quartile, you can call it first quartile. Variable Y has more dispersion. Why do we say that it has more dispersion? Remember, measures of dispersion are range, variance, and standard deviation. If we look at this, for instance, the range is, of course, the maximum minus minimum. The range of Y is greater. See, this is like 110, like 110 minus 0. And this is like 20, maybe 20 something. Okay, maybe 27 minimum here. And this might be 70 something, maybe 75. So you see, the range of Y is more than the range of X. And also the interquartile range. The interquartile range is Q3 minus Q1. This will be 40, maybe 48. Okay, 48 minus Q1. Q1 is 10. 48 minus 10 is 38. Okay, then here Q3 is maybe 50. Let's say maybe 53. And the Q1 is 30. Q1 is 40 something. 40 something. 50 something minus 40 something is like 12, 14, 13, 14. So you see, this is more. Okay, this is more. 48 minus 10, 38 is more than that, like 13 or 15 or 14. Okay, so the range is more, the interquartile range is more. Variable Y has more dispersion. And the shape of variable X is symmetric. Yeah, it's symmetric. Why do we say it's symmetric? If you look at this, the median is almost at the center of the data, which is 50. Okay. It's almost equally spaced. Okay. From the median to the lower quartile is approximately from the median to the upper quartile. Also, the whiskers are almost the same. The whiskers are almost the same. If you calculate it, it's almost the same. And also, the distance from the median to the minimum point is also approximately equal to the distance from the median to the maximum point. So we say it's symmetric. In Y, we say it is skewed right. Okay, how do I know? First of all, the easiest way to know is this. Assuming you're doing that distribution, you know, if you draw like a normal plot here, you see the tail end of that normal plot is like here, kind of skewed right, just like we did in the histogram. Okay, this is like more of this than like this, so it's kind of skewed right, but that is kind of an easy way to know. But if you really want to know more, you see this is why. From the median is turns more towards the left of the data. Okay, then from the median, the distance from the median to the lower quartile is less than the distance from the median to the upper quartile. Also, another easy way to know this is that the right whiskers the right whiskers is greater than the left whiskers. That is another way to know this easily. Right whiskers is greater than the left whiskers. You see that? Also, the distance from the median to the minimum point is less than the distance from the median to the maximum point. So it's skewed right. Comprenez-vous? This video will be long, right? I know. In this one, y is skewed left. Okay, the left whiskers is greater than the right whiskers. Left whiskers is greater than the right whiskers. Easy way to know. Or you see that if you kind of draw it like this, you see that this tells more here. The median tends to shift right of the data. The distance from the median to the lower quartile is greater than the distance from the median to the upper quartile. Also, the distance from the median to the minimum point is greater than the distance from the median to the maximum point. Okay, this is skewed left. And also, variable y has more dispersion, of course. The range of y is more, the interquartile range of y is more. 5-number summary of the data. 5-number summary of the data. So we've done, we've done something like this with technology. Just you can, is the same way. You only need to now put in minimum and maximum. If we do that, let's go ahead and do this one, and you see how it's done. The only thing you need to add more is the minimum and the maximum. That is the more information you need to add. Let me use variable 7 here. So this is 57, 50, 55, 48, 68, 65, 57, 62, 43, 43, 48, 56, 58, 64, 49. All right, so summary starts columns. I want only variable 7. I can put sample size, doesn't matter. I press my control key. I need the minimum, then I need Q1, then I need, if you want it to be like how you need it, then you have to select it that way. Then I need median, then I need Q3, and then I need maximum. That is what I need. Compute. So this is the 5 summary data. You know what? Let me not put sample size. Yeah, because this is just 5 summary data. We don't need sample size. Variable 7. Then I need the minimum. I need Q1. I need median. I need Q3. And I need maximum. Okay, that's the 5 summary data of 5 number summary. I mean 5-number summary of the data. And of course, if you do it with hand, we have done it with hand. The only thing is just to find the minimum of this data. The minimum is 43 and the maximum is 68, which you can just find from the data. Okay. What is the shape of the distribution? All right, let me show you how you can draw the box plot. You come back here. This is the 5-number summary. Let's draw the box plot. You go to graph. You click box plot. Box plot. Select variable 7. You want to check this, okay? You want to make sure you check these two things. Use fences to identify outliers and also draw boxes horizontally. Make sure you check both of the boxes. And then you can compute. And there you go. This is the box and whisker plot. So the left whisker is equal to the right whisker, approximately. Okay? And this is roughly symmetric. Okay? And if you point your mouse on it, tells you the interquartile range, the lower limit, which is the lower limit is the minimum. Okay? The upper limit is the maximum. Gives you the 5-number summary if you point your mouse at it. All right? Okay. Here the distribution is skewed to the left. The left whiskers is more than the right whiskers. Here the distribution is skewed to the right. The right whiskers is more than the left whiskers. Okay, folks, thank you for listening. I know it's a long video. Thank you so much for listening. And you have a great day.